sine of alpha. And then finally, the cosine, or the sine of alpha goes here, followed by the cosine of alpha. Now, don't feel bad if you don't necessarily see that, because I generally have to look it up to keep it straight, especially when I'm not staying on top of things real well. If I go away from this for a while, come back to it, I pretty much have to go back and look this up to make sure that I get the negative sign in the right place. I always lose track of that negative sign for some reason. And then finally, what about our rotation about the x-axis? This is really small down at the bottom. We're going to be leaving the x component unscathed. And then it's just going to be cosine, negative sine, sine, cosine. So cosine alpha, negative sine of alpha, sine of alpha, and cosine of alpha. Which one of these are we going to be using primarily?
Use our z.
What's that?
Rotation about the z.
We're going to be using the z, because what we're going to do is we're going to say that that z passes directly through the joint of rotation. And therefore, we're going to be rotating about z whenever we place a motion on a joint, a revolute motion on a joint. Okay? So this is the primary transformation that we're going to use throughout this course. Now, in addition to that, we're going to be talking about the DH parameters, which we'll get to in chapter 3. But these DH parameters account for such things as twist on a joint. So for example, sometimes you have a twist on a joint. Maybe the joints aren't aligned parallel or perpendicular to each other, as well as physical displacement from the center of travel on the joint to the next joint. So if this joint was shifted over here, then we could go through and look at a characteristic in this DH parameter list in order to account for that. That makes sense? So, virtually everything that we do will be a matter of modifying our z rotation transformation. We can make the alpha angle in our z transformation a variable and sit there and rotate objects through space that will model the motion on our robot. Good? All right, so what I will do is I'll go through, where we're going to go is next week we're going to spend a day digging into this deeper, merging the translation transformations with the rotation transformations, and then going through and actually start looking at some examples of how we can look at different rotations and translations on the robot. So what I'll do is I'll review this video, see how it did. If this magnet idea actually worked and maintained focus throughout, I might just stick with it, even though it's somewhat cheesy. Because frankly, my wife didn't like the idea of me using her camera in the first place. So if that does work, I'll just stick with it. Otherwise, I'll make my wife unhappy.
Oh, that's what she gets for getting you back into playing WoW.
Yeah, I guess so. How's the, other than the work, first assignment and the video issue, how's the first week of class feeling? It's going to be a really quick class. I mean, trying to do this over a 6-week session is going to be really crazy.
When you're done, I have a question about 301.
Okay, yeah, that's cool.
Yeah, that one was.
Okay, and with that, I am done.
I